Once again, good morning and welcome to our Mathematics 9 class. Today, we are going to talk about another topic in trigonometry, and it is called the law of sines. You might ask, will there be a law of cosines, tangent, cotangent, cosecant, and secant? In trigonometry, we have three common laws: law of sines, law of cosines, and law of tangent. But law of tangent is not commonly used because it can be covered by law of sines and by the law of cosines. So basically, we will only have the law of sines and the law of cosines. To start with, let's recite today's memory verse. And it's found in Proverbs 11, verse 3. It says, "The integrity of the upright will guide them, but the crookedness of the treacherous will destroy them." Your MVCA boosters today is to reflect on these diagram. You see here the formula for a healthy relationship is to have God at the center. You need to write 3 ways to maintain a healthy relationship. After this activity, we are going to meet the following targets. First, illustrate the law of sines, and the second, solve problems involving oblique triangles. Before we go further, I want you to check on these ones. Now, can you tell me, what do you see in the picture? Janine? What do you see in the picture? What's common?
Last like triangles, ma'am.
Very good. Triangles. Now, aside from, like you will see here, the triangular shaped volcano, the succulents, the flower, and even the dorsal of the dolphin. What else? What objects in nature can you see triangles? How about Jared and Tatiana? And also Ali. Where's Ali? There. What objects in nature can you see triangles? There's Tatiana and Ali and Jared.
Ma'am, oftentimes see triangles and mountains. And
Yes, you're muted. So you see, triangles are not only found in buildings, but we also see them in nature. Now let's continue. Now there are 3 classifications of a triangle based on its angles. While we have isosceles, scalene, and equilateral, we can also classify the triangle based on its angles. You see in the first figure, if the triangle has 3 acute angles, we first annotate. If you see 3 acute angles in a triangle, these 3, we call this triangle acute. In the previous lesson, we have talked about triangle with 1 right angle and 2 acute triangles. We call it a right triangle. The other one is the obtuse angle. The obtuse triangle has 1 obtuse angle and 2 acute angles. So these are the 3: acute, right, and obtuse. Now, how is this lesson different from our previous lesson? In the previous lesson, we have talked about right triangles. But for this lesson, we'll be talking about an oblique triangle. Now, what is an oblique triangle? An oblique triangle can be an acute triangle, or it can be an obtuse triangle. These are triangles with no right angles. So if you'll have this one, this triangle with a right angle, we call it right triangle. But if you'll see different triangles without the right angle, then we call these oblique triangles. Now, once we solve for oblique triangles, we could not make use of the SOHCAHTOA CHOSHAHCAHO. The SOHCAHTOA CHOSHAHCAHO can only be applied in right triangles. If it's not a right triangle, then we use either the law of sines or the law of cosines. Now, when do we use the law of sines? You use the law of sines if two angles and a side are given. Example, let me first teach you how to name the sides and the angles. Angles are named using capital letters. So we have A, B, and C. How do we name their sides? The side opposite to angle A is called side A. Sides are named using small letters. So if this is A, the opposite is side A. If this is angle B, its opposite side, this one, is called side B, a small letter B. If this is C, the opposite is side C. Or sometimes we name the side using the two points. So for example, if you have side C, we can also name it as side AB. Now, we use the law of sines if two angles and a side is given. Example, angle A and angle B are given, and side A is also given. Two angles and one side. So we use the law of sines. Or another, if we have two sides and an angle. Example, side A and side B are both given, and angle B is also given. Therefore, we use the law of sines. Or let me share you my technique. Once there is one complete pair of side and angle, then you use the law of sines. Example, angle A and side A are given. If you want to find for another side or another angle, you use the law of sines. Now, what's the formula for the law of sines? This one. Sine A, that's angle A, over side B is equal to sine angle B over side B, and it's equal to sine angle C over side C. Or you can have the sides in the numerators first. You'll check the pattern. Sides A, B, C in the numerator. In the denominator, we have sine of angles A, B, and C. You don't need to have the three. You can just have a pair. Now let us have the first exercise. Now in this exercise, we have the given. Angle A is 54.3 degrees. Angle B is 47.6 degrees. And side A is 25.8. Here's a technique. Before you start solving, I suggest you draw your triangle. A, B, and C. The measure of angle A is 54.3 degrees. The measure of angle B is 47.6 degrees. And the measure of side A is 25.8. We'll be looking for the missing angles and sides. So we're looking for angle C, also for side C and side B. Here's how you check on it first. Identify what is the side and length, the side and angle that has a complete pair. You'll see here we have angle A and side A. So that will be our complete set. How will you know what's the first one to solve? You check on the given. Our given is angle B, so we can start by solving for side B. So let us now start. We have sine A over side A equals sine B over side B. Now we have sine, our angle A is 54.3 degrees over A equals sine 47.6 over side B. Sorry, our A is 25.8. Our B is missing. So what we can do first, we cross multiply. So we now have B sine 54.3 equals 25.8 sine 47.6. We want to solve for B. So for B to remain, we need to divide both sides by sine 54.3. So cancel it now. We're left with B. Then what are you going to do next? You get your calculators because you don't have any other choice. We need to use our calculators for this and encode these numbers. You have 25.8, if you can see my calculator, sine 47.6 divided by sine 54.3. Here's our answer. You write it in 2 decimal places. We have B is approximately 23.46. So we now have B equals 23.46. We now have a complete A. We also have a complete B. Now we'll start solving for C. But if you check, we don't have one representative for C. The angle is missing and the side is missing. And you need to have at least one before solving. So how are we going to solve for angle C? Now, can anyone tell me what is the sum of all the angles in a triangle?
180 degrees.
Good. It's 180 degrees. So we need to subtract angle A and angle B from 180 to get angle C. Now, what's the answer? What's the measure of angle C? Anyone? Any answers? We'll have 180 minus angle A, 54.3, minus angle B, 47.6. the measure of our angle C is 78.1. So we now have 78.1 for C. So this time, we're going to solve for side C. Let me first erase this. Let's use the complete given. Sine A over A equals sine C over side C. So you have sine 54.3 over 25.8 equals sine angle C 78.1 over side C. Now, can anyone tell me what are we going to do next? What are we going to do next? To solve for C.
Multiply.
Very good. We cross multiply. Remember that any number or any variable will go first before the trigonometric sign. So C should go first. Do not place it afterwards, or else your answer will be wrong. Equals 25.8 times sine 78.1. We need to solve for C. Can anyone tell me what are we going to do next?
Divide all sides by C.
Oh, no. If we divide all sides by C,
Oh.
we're left with sine. Divide both sides by
Sine 54.3.
good. Divide both sides by sine 54.3. Because if you divide both sides by sine 54.3, it will be canceled out on the left side and we'll have C left. So C is equal to. Now, can anyone tell me what will we do next? What should we do next to solve for this one?
Divide them.
Yes, we need to divide them and you need to use your calculator. So we have 25.8 times sine 78.1. Divide them all by sine 54.3. Our answer is approximately 31.09. So this is 31.09. All our angles ABC are present and our sides ABC are also solved. So again, let me repeat to you, let's have a review on the different techniques. First, if two angles are given, you just subtract the last angle from 180 to find its measure. Then, to find for a missing side, find a good pair, a complete pair, and you start with the other side that is missing, given the angle. Write them in this trigonometric ratio, substitute the values, cross multiply, then divide all by the sine function that goes with the variable. Then use your calculator and you can now solve for the missing length. Any questions before I'll go to the next example? If you don't have questions, give me a thumbs up. Oh, very good. Now let's go to the next example. Here's the next example. we have side A is 2.5, side B is 4.3, and angle A is 46 degrees. Again, we start by drawing our triangle. It's A, B, C. And this will be side A, side B, and side C. Side A is 2.5. We label it. Side B is 4.3. And angle A is 46 degrees. Now, can you tell me what side and angle is a complete pair in this example?
Angle A and side A.
Very good. Angle A and side A. Now, why is it important to determine the complete pair? Because that will be your first trigonometric ratio, sine A over side A. Now, what will be the first angle that we are going to solve? What should we solve first? Angle B or angle C?
Angle B.
Angle B, because our given is side B, so we must solve for angle B. So let's have sine B over side B. Let's substitute the values. Sine 46 over 2.5 is equal to sine B, it's missing, over 4.3. What are we going to do next? What should we do next?
Cross multiply.
Very good. Cross multiply. So these two, 4.3 sine 46 equals the other one, 2.5 sine B. Now we want to solve for sine B, and it has another companion, 2.5. So we should divide both sides by what number?
2.5.
Very good, by 2.5. So that you'll cancel it, and we're left with sine B. So we have sine B equals 4.3 sine 46 over 2.5. But we're only looking for B, for angle B. And there's still a sign here. How do we get for the value of angle B? How should we write it in our calculator? Remember, when the angle is missing, we need to use the sign to the -1 function. So B is equal to, have this in sign to the -1. So let's use our calculator. That's going to be shift sign. So we have sign to the -1 function. Then in our numerator, we have type 4.3 sine 46 over 2.5. There. What does it say? It say 90.38 and there's an I at the end. What does it mean? It means that we don't have a possible answer for angle B. Let me show you why. Let's first solve for this one before the -1 function. Let me show you in the calculator. I think many of you have seen this when we had our lesson 7.2. Many answers are no answer. 4.3 sine 46 over 2.5 here. If you solve this one, the answer will be 1.23. And you know what? The sine function and the cosine functions cannot be more than 1. So since this is more than 1, so it means that there is no answer. What do we mean by no answer? It means that this triangle is not a possible triangle. Okay? Now let's go to the next one. Let me have the last example, then we'll go to the problems. Okay. Can you tell me what's the given? What's our given? Based on the figure.
We have B, ma'am, with angle B, 22
Very good.
degrees.
We have angle B. Sorry,
22 degrees.
give me a moment. There. Angle B is 22.
22.
Yes.
Then angle A, 180.
Angle A, 118. What else?
And side C, 24.
Side C, 24. There's no pair, right? But you can solve for angle C to find a pair. What's the measure of angle C? What's the measure of angle C? We subtract it from 180.
40 degrees.
Okay, let me use my calculator. Somebody answered 40 degrees. That's correct. 180 minus 118 minus 22. There. The answer will be 40 degrees. So our pair will be C. Since that's our pair, I suggest you start writing your pair here. There. Other ways to solve it better. Let's check if we can solve with the ratio first. Sine C, what's our sine C? 40 over 24. If you want to solve it first so that you don't keep on answering, but the disadvantage is you need to copy all the numbers to get an accurate answer. This one, you could start solving with this, but the problem is you need to copy all of this. Now, let's start solving for side A. So we have sine A over A. So sine 118 over A. And while I'll solve here, you also solve individually and you type your answer in the chat box. Cross multiply A sine 40 equals 24 sine 118. Divide both by sine 40 . What's our answer?
33.
The answer is 33. Very good. Let me verify it using our calculator. 24 sine 118 over sine 40. There. The answer is 33.97. But if you want to make it as a whole number, then we can write it as 33. Now, what can be your hint? Ma'am, how will I know how many decimal places am I going to use? I missed that in the previous one. You check on the side. If the side is a whole number, then it means that the rest of the sides will also be whole numbers. Like you might ask, ma'am, why didn't we use 32.97 here? It's more accurate. Yes, it's more accurate, but if you check on this one, it's a whole number. So your side A will also be a whole number 33. Now let's solve for side B. We have sine C over C equals sine B over B. So sine C. Sine, while I'm writing here, you start answering. We have sine B is 22 over side B. Cross multiply, we have B sine 40 equals 24 sine 22. Divide both sides by sine 40. What's the answer for side B?
14.
14. Very good. Let's verify that with a calculator. You have 24 sine 22 over sine 40. There. The answer is 13.98. But again, if the side are whole numbers, you need to write it all in whole numbers. So we have 14 for the answer for B. Any questions? Or give me a thumbs up if it's already clear with you. Okay, thank you for that. Now I will no longer solve the next figures because it's very similar to these figures. We'll now go to the problem. Here's now a sample problem. Juan and Romelia are standing at the seashore 10 miles apart. Again, once you're solving with problems, it would be best if you can draw it. So start with the illustration. So Juan and Romelia are standing at the seashore and they're 10 miles apart. So you write here 10 miles. The coastline is a straight line between them. Both can see the same shape in the water. So you draw the shape on the water, and the angle between the coastline and the line between the ship and Juan and the line between the ship and Juan is 35 degrees. Sorry, this is already a repetition. Let me delete that part. It's 35 degrees. So it means from Juan to the ship, the angle is 35 degrees. Next, the angle between the coastline and the line between the ship and Romelia is 45 degrees. So this one. How far is the ship from Juan? So we're looking for the distance of the ship from Juan. So we write there X. Now, how are we going to solve this first? I suggest you name your angles. Angle A, angle B, and angle C. Based on this given, what are now the given angles? We have angle A is 35 degrees. What else?
Angle B,
Angle
45.
B is 45. And then what else is given? What is the 10 miles there?
Side C, ma'am.
Side C, 10 miles. And you don't have an angle C. So we need to solve. What is our angle C? Subtract these two from 180. What's the measure of angle C?
100.
100. Very good. So angle C is 100 degrees. Now, what are we looking for? What side are we looking for?
Side B.
Side B.
Side B.
So if you don't want to get confused, you could just name it B. So let B be the distance from Juan and the ship. So we're looking for side B. You write the complete set. equals the one with a B. Sine B over B. Okay, well, I keep on writing. You need to start solving. Sine 45 over B. Cross multiply. We have B sine 100 equals 10 sine 45. Divide both sides by sine 100. What is the answer for B? How far is Juan from the sheep?
7 miles.
7.18 miles. Oh, very good. Ma'am, what will happen if it's in the problem solving? If it's a figure solving, if the side is a whole number, you can also have a whole number for the other sides. But in problem solving, you need to be accurate. So write the answer up to 2 decimal places. The answer is 7.18 miles. Juan is 7.18 miles away from the sheep. Now, I only have